Okay, hey everybody. Today we're doing Chapter 5, Section 5, half-angle formulas. So 3 new formulas that we're going to be using. The first one is the sine of u over 2 is equal to positive or negative square root of 1 minus the cosine u all over 2. All of that is under that square root. The positive and negative we're going to talk about in a minute, but that's going to come from which quadrant where we find u over 2. The cosine of u over 2 is equal to positive or negative square root of 1 plus cosine u all over 2. And we are going to go ahead and write a formula for the tangent of u over 2. It is equal to 1 minus the cosine of u over the sine of u, or the sine of u over 1 plus the cosine of u. And also the tangent of u over 2, we can also use definition of tangent and use the sine of u over 2 over cosine of u over 2. But actually sometimes this is going to be, either one of these will be an easier formula. All right, so example 1. Let's find the exact value of sine of pi over 12 using the half-angle formulas. Now the sine of pi over 12, we actually could find this using our difference formulas, the sine of x minus y. But this time we're going to do a problem we may have done in an earlier section, but we're going to use this particular formula. So we're going to find the sine of pi over 12. So a couple of things we need to do here. First of all, we need to look at the angle pi over 12 and determine which quadrant it's in, because with the quadrant that it is in, it's going to help us determine whether to take the positive or the negative square root. Pi over 12 is in quadrant 1. So that means our answer is going to be a positive answer. So the sine of pi over 12, since that's in quadrant 1, is going to be positive. Another thing we need to think about is pi over 12 can be written as 1/2 of what angle? Because that's what the sine of u over 2 means. U over 2 means 1/2 of u. Those are equivalent statements. So pi over 12 is 1/2 of what angle? Well, it's actually very, very simple to figure this out. All you're ever going to do is take that denominator and divide it by 2. The numerator is just going to stay the same. So this will be pi. Divide your denominator by 2, we get 6. So pi over 12 is just 1/2 of pi over 6, because this angle, this is our angle u that we're going to be using in our formula. So the sine of pi over 12 becomes the sine of 1/2 of pi over 6. So that's going to be the square root of 1 minus the cosine of pi over 6 all over 2. Cosine of pi over 6 is just on our chart. So that's 1 minus the square root of 3 over 2 all over 2. So now we've got this pretty yucky answer, and we do need to simplify it somewhat. First of all, we have a fraction within a fraction. So if you remember or not, to simplify this complex fraction, we're going to multiply every single term by the denominator of this little fraction here. So in other words, I'm going to multiply everything by 2. So I'm going to multiply here by 2, this times 2, and the denominator by 2. So that becomes the square root of 2 minus, when I multiply square root of 3 over 2 by 2, those 2's cancel. So I just have the square root of 3, and then it's all over 4. And now there's actually one more step we need to do to simplify this square root. The square root of a fraction, we can split that up and take the square root of the numerator, which is 2 minus the square root of 3, over the square root of the denominator, which is now a 4, from where we multiplied everything by 2. And the square root of 4 simplifies to just be 2. So our answers to these are going to look a little strange, because we're going to have sometimes square roots within a square root. But that is the exact value of the sine of pi over 12. Square root of 2 minus the square root of 3 all over 2. And again, we chose positive because the original angle, the pi over 12, was in quadrant 1, where everything is positive. So our answer there is positive. So there's example 1. All right. Example 2. We're going to find the exact value of something a little more complicated. Let's find the exact value of, let's see, the cosine of 7 pi over 8. Cosine of 7 pi over 8. All right, so first of all, 7 pi over 8, which quadrant is that in? Well, 7 pi over 8 is bigger than a half of a pi, because a half of pi would be 4 pi over 8. But it's smaller than a pi, so this is in quadrant 2. And in quadrant 2, cosine is negative. So we're going to take the negative in front of our square root. Then we need to figure out 7 pi over 8. We need to write that as 1/2 times an angle. And again, all you have to do is divide that denominator by 2. So the 7 pi stays the same. The numerator stays the same. 8 divided by 2 is 4. So 7 pi over 8 is 1/2 of 7 pi over 4. So this is our u value that we're using in our formula. So the cosine of u over 2, or 1/2 u, is going to be, and it's usually positive or negative, but we've already figured out that since this is in quadrant 2, we're going to take negative, and it's the square root of 1 plus the cosine of u, which in this case is 7 pi over 4, all over 2. So there's a very small difference in the formulas for the half-angle formula for sine, half-angle formula for cosine. So this is going to be negative square root of 1 plus. Now the cosine of 7 pi over 4, since that's not in our first quadrant, that's going to take a few steps to figure out. But it's all old stuff that we've done. So 7 pi over 4, I can write that as 1 3/4 pi. Which that just tells us that that is in quadrant 4. In quadrant 4, cosine is positive. So the cosine of 7 pi over 4 is going to be a positive number. Our reference angle is pi over 4. So the cosine of pi over 4 is square root of 2 over 2. And then it's all over 2. So now to simplify this, I'm going to multiply every single term by 2. So that becomes the square root, a little negative on the outside, of 2 plus the square root of 2 all over 4. And again, what I did here, since it was a complex fraction, multiply each term by this denominator. So 2 times 1 gave us 2. Here the 2's cancel, so we're just left with the square root of 2. Denominator is 4. Give the numerator and the denominator their own little personal square root. And our final answer is negative square root of 2 plus the square root of 2 all over the square root of 4, which is 2. And again, these answers are going to look a little different. So there's example 2. All right, one more example. It's going to have multiple parts. All right, last example. Let's use the diagram to find some values. So let's be given this diagram. I'll say that this is my angle theta. And we're given these two sides, 5 and 12. So let's find the exact value of part A. Let's do the cosine of theta over 2. Well, to find the cosine of theta over 2, I need the cosine of theta. So from this diagram, here's my theta. Cosine is adjacent over hypotenuse. Well, we're missing this hypotenuse. Use your Pythagorean theorem, or you may remember your triple. And we're missing the hypotenuse of 13. So our cosine of theta is adjacent over hypotenuse. So for the cosine of theta over 2, so notice this time we don't know what the angle is, but we don't need to. This is, for one thing, since it's in a triangle, it's always going to be positive, so we don't have to worry about the plus or minus that is out in front. For cosine, it's 1 plus the cosine of theta, which we found to be 12 over 13, all over 2. So that's going to be, let's see, now we need to multiply everything by 13. So we're going to multiply each and every term by 13 because that's the denominator of that fraction. So this is the square root of 13 plus 12, all over 26. So that's the square root of 25 over the square root of 26. So that's 5 over the square root of 26, which we need to rationalize. We get 5 square roots of 26 over 26 for our final answer. If we wanted the sine of theta over 2, all we need is the cosine, which we already found is 12 over 13. I'll just write the formula real quickly. The formula for the sine of theta over 2 is 1 minus cosine of theta, all over 2. So that's going to be the square root of 1 minus 12 over 13, all over 2. Multiply everything by 13. We get 13 minus 12, all over 26. So that's the square root of 1 over the square root of 26. Square root of 1 is just 1, so we have 1 over the square root of 26. Rationalize that, we have square root of 26 over 26. If they want the tangent of theta over 2, I'm going to bring this over here. And this is a formula we haven't used yet, so I'll remind you what it is. It's 1, I'm going to use the first one, 1 minus cosine theta over sine theta. Let me just delineate this here. All right, so we know what the cosine theta is. It's 12 over 13. The sine of theta is going to be the opposite over the hypotenuse, so the sine of theta is 5 over 13. So now I'm going to plug my values into this formula. So tangent of theta is going to be 1 minus our cosine we found was 12 over 13 over sine, which is 5 over 13. So again, we're going to multiply each and every term by 13. So we end up with 13 minus 12, because those 13s are going to cancel, over 5. So our answer is 1 over 5. And just as one other little example, a quick example, if they asked you for something such as the cosecant of theta over 2, well, remember cosecant is just the reciprocal of sine. And we've already found the sine of theta over 2 to be, I'm going to back it up one step, 1 over the square root of 26. So when we take the reciprocal of that, we just get square root of 26. So when they ask you for secant or cotangent, just take the reciprocal of one of your previous answers. And that's it for today. Thanks.